Welcome back. Tonight's segment of Solving Quadratic Equations is being brought to you by Completing the Square. So far, we've learned how to solve quadratics by graphing and locating the x-intercepts, also known as roots, solutions, or zeros to the problem. We've also learned how to solve quadratics by factoring. Not all of us love factoring. And graphing and factoring both are somewhat limiting in the answers that we can get. Not everything can be solved by graphing or factoring, which is why we have the quadratic formula, which will solve any quadratic for us, which is kind of nice. And tonight, we're going to learn about completing the square, which will also work on any quadratic. We use this one because you will need it moving forward to higher level maths, like in functions trig or calculus. And quadratic formula can sometimes leave a lot of room for error with signs or calculations and things like that. So it's nice to have an alternative. It's also good just for checking your answer and seeing if you get the same thing. So we're going to start with a fairly simple problem. And we do need to keep in mind that a perfect square trinomial is going to be necessary to solve a quadratic by completing the square. So I put the formulas for perfect square trinomials up here. Please come see me if this doesn't make sense to you. You are definitely going to need this moving forward. A perfect square trinomial is a three-term expression, 1, 2, 3, 1, 2, 3, where your first term and your last term are perfect squares, and your middle term is specifically twice the square root of your first and last term. So, and it can either be positive or negative. It just changes the way we factor it. So if we take a look, this could potentially be a perfect square trinomial. We have three terms. The first term is a perfect square. The last term is a perfect square. But if you notice, that last term has to be a positive perfect square, and we have a negative. And the middle term is not double the square root of x squared, which is x, and the square root of 16, which is 4. So 4 times x would give us 4x times 2, which would give us a middle term of 8x, which we don't have. So this is not a perfect square trinomial, though it kind of looks like one. We can solve it, however, by completing the square. So let's see how to do that. The first thing we want to do is to um, get this number out of the way. We don't want it anymore because this is not a perfect square trinomial, and we want to make it one. So we add 16 to both sides, which gives us x squared plus 6x equals 16. And then we're going to add a number over here. I'll show you why. Okay. So if you come over here, x squared plus 6x plus some number is going to be our new perfect square trinomial. The question is, how do we figure out what that number is? Well, we're going to kind of work backwards from our formula for a perfect square trinomial. This middle term has to be 2 times the square root of the first and the last term. So the x is already there. So 6 has to be equal to 2a. So if I take 6 and I cut it in half, I get 3. So this last term has to be 3 squared, or 9. So that's what we want to add. Unfortunately, what we do to one side, we have to do to the other. We can't add 9 to one side unless we add it to the other side as well, which gives us, now we can factor that perfect square trinomial. Oops. X plus 3 quantity squared, and then the 16 plus 9 gives us the 25. So I can now solve this by taking the square root of both sides, and I get x plus 3 equals plus or minus 5. Anytime we take the square root of a positive integer, we need to take the positive and the negative roots. So if the x is positive, when we subtract 3 from both sides, we get negative 3 plus 5, which would give us 2, or negative 3 minus 5, which would give us negative 8. So our two answers would be x equals 2 and x equals negative 8. You could get this by factoring. You could get this by using the quadratic formula. This is just another way. You could actually even do this one also by graphing. It's really kind of, you know, whatever you feel the most strongly.